and yeah, so the first one is Baptiste Bouchy. Yeah, okay. So yeah, welcome, and you have 5 minutes, and yeah, warm applause for him, please. Put it to the top.
Okay. Oh.
Good.
So hello everybody. I'm Baptiste Bouchy. I work at Femto-ST, the OmniDisk team in Belfort at the UTBM school. So I work on Programmable Matter. So the idea is to have a huge number of small identical robots who are all connected to each other physically. We maintain at all time the connectivity, so each robot always need to be connected to at least one other. So we have this huge stack, like we can see on the picture on the top right. So we can have like a cube of identical robots, and we want to shift it to another shape. So we have to move each robot by turning around each other to achieve a new shape. So the idea is to be able to take this robot and change its shape anytime we want, just like 3D printing, when you want to create something, but instead of creating something, we just shift the creation every time we need something new. So there are many things we have to do in order for this to be more practical. First, design these robots. But after we have to, for the software problems, we have to design distributed algorithm for them to work together. What we want to do to change the shape? Do we want to remove the shape and construct it next to the initial shape? Do you want the robot, to shift around each other to stay in the same position but achieve the new shape? So what I did personally is I proposed a new algorithm to change the shape, and we are building a machine learning tool to help us decide what is the best algorithm in order to make the shift, because we have a huge number of robots. So just shifting, just removing or adding a robot can change a lot in the application. It can create a hole. It can prevent us to do some scaffolding. So it's really important to choose the right tool, to choose the right algorithm, because the energy of the robot is really important. Because the robots are so small, there are a lot of issues we find that now are less important in computer science. We have issues about energy, about computational power, about all that. Because the robots are so small, we don't have a lot of these resources. So it can be a really important tool to be able to choose what are the best way to shift the robot from the initial to the final shape. Yeah, I think I finished. Went a little fast, sorry.
Perfect. So yeah, very, very, very interesting. So thank you very much. And just switch to the next one. The next one is Julius Bünger. Julius, warm welcome. Yes. And the stage is yours.
Good morning, everyone. I'm Julius Bünger. I'm from Rennes, from IMT Atlantic. I work with Marc-Oliver, Pahl, and Nicolas. I just started, so I have a topic, but I just looked into it. We go into it. My topic is mostly about classification and managing of secure IoT environments. That means that has a lot in mind the mindset of, okay, we have devices, sometimes they go out of life. When they go out of life, what do we do with those devices or with parts of them? So we need to have a classification scheme to see what is actually there, what does this device do, what can the components do, how can they be repurposed, or what other purpose can we give to them? So that's the overall big topic. As we just started, we're looking, and it's a very, very big area. We started looking at updating IoT devices or deploying those. So what we currently do is look what's already there, and we see lots of different approaches that focus on different problems of different challenges at different levels, at different focuses. So we can, for example, see that most of the, or one area of publications is looking mostly into the scalability of that. So with the claims of we will have billions, whatever, huge numbers of devices, and they all want to get their updates, some servers might be overwhelmed, the network might be overwhelmed, different things on that level. Then the IoT devices, they have constrained hardware, so they might not be able to. This is mostly interesting when it comes to security. Most of the IoT devices won't be able to run the proper cryptographic means that we can run on our day-to-day computers. So we have to find solutions there. So there are different problems, and there are a lot of different approaches. And as we're currently at the start, we will see where we're going into, and this is the overall picture that we're having now, and I'm very curious where that will go into.
Perfect. Thank you very much. Very good, and I have to know to myself, I always tell the people they only have 3 minutes, because then they perfectly stay within the 5 minutes. Wonderful. Thank you very much also for that very interesting presentation. Let me switch to the next one. It's Ahmed, Amin, Shafir, and Ahmed, warm applause for you. And the stage is yours.
Thank you. Hello. So my name is Ahmed Amin Shafir. So I am a PhD student working at Future-IoT lab with Omni teams, with some industrial engineering backgrounds, and I'm working on programmable matter. So technically, I am at the same lab, at the same team with Baptiste, but here we looked at programmable matter in different approach. So programmable matter is generally defined as a collaboration of system of elements that tends to create and alter between different formation. But here we talk about a new definition of programmable matter. So we thought about what is it possible to find matter that already exists in nature and have some embedded intelligence. So instead of looking of thinking about systems with CPUs and actuators and sensors, is it possible to find matter that have already that embedded? And we have looked out in nature, and we have found that there is things that already exist, and we didn't think of it. So like sunflowers, they have sensors to feel the sun and the actuators to follow it. There is also some metals that expands whenever they heat, so they act like actuators and sensor. And what is most beautiful that they also have memory, so they can store up to 1 or 2 shapes. So generally, I work on materials, and most precisely, I work on designing interfaces for 4D prototyping and actuation. So my research questions are more about the behavior materials. How can I represent this behavior? Is it representable by equations, or can be simulated or represented, or can be controlled precisely, and how to do it? So my thesis is about to answer to all these questions. And what I am now currently I am in need of finding a way to precisely simulate these materials, because The problem here is these materials are meta materials. So meta materials that are materials that are highly customizable. So we need either to do physical tests or to develop our software to do simulations. But we found different solutions that we are working currently on. So until now, we have developed many devices. So we have 2 patents. The first patent is the one that you are seeing now. So this is a membrane. So we have metal that can create bumps. And combining different nodes, we can create 2.5D shapes. So it is just a deformable surface that can serve as a braille, dynamic braille screen, or also for representing geometrical interface dynamically. And we have developed another model that we have changed the structure, and the patent is ongoing. So we hope that we get an answer the following month. So this is what I am currently working on, and I'm very happy to answer your question or to develop more if you are interested.
Perfect, thank you very much. And as you mentioned it, so the idea with the questions is that exactly we take them to the lunch break, because there you meet each other and then you can continue discussing about the topics. Yeah, the next one is Alice Chier, and Alice, I directly hand over to you in that direction. So here's your poster, and we are looking forward to your presentation, and also a warm applause for Alice.
So, good morning, everybody. I'm Alice, and I'm first-year student, so in PhD student, sorry. So my topic is sensitive device identification through learning of radio frequency fingerprint. And the first word, sensitive, is due to the application context. So maybe you know tempest attack. So an attackant would attack a device, and to attack it, he wants to identify. So the sensitive identification is about this. So to manage this identification, we interest on the radio frequency fingerprint. So the radio frequency fingerprint is a signature, is a unique signature of a radio device. And this signature is due to the due to analog component and the singularity of this analog component. So after 2 months of reading, the state of art helped me to develop some scientific logs. Sorry, and so the first logs is algorithm, because we have many possibilities to identify radio frequency fingerprint. And for example, we can use a parametric algorithm, or we can use the deep learning algorithm. So the state of art is show many possibilities. And the other scientific log is data. Data, because we have many possibilities. For example, we have to choose data. We can do some Fourier transform, or we have to choose the quality or the quantities of data. So data is very important, and some authors propose modelization or experimentation. So we have to choose that. And another point of data is data perturbation, because for example, the channel and the receiver front end could impact or the radio frequency fingerprint, and we don't want to to classify it, we want to classify just radio frequency fingerprint due to the transmitter. So to conclude with my little presentation, this is the general flow of RF fingerprint identification based on the state of art. And so on the first part, we have the device 0 and device 1, because we can have many devices on the environment. Sorry, and every device has his radio frequency fingerprint, and it's unique. And so we have a legitimate receiver, and the objective is with a software-defined radio, intercept the signal and processing it. So, for example, apply a Fourier transform, and next extract the RF fingerprint and do the classification. Thank you.
Thank you very much. So you all have very interesting topics, very good. I'm impressed, and also great presentations so far. All right, so the next one on the list is Alexis Duarmel, and Alexis, also for you a very warm welcome. Yes, you can clap your hands. And,
hello everyone.
And we're eager to hear about your topic.
Thank you. So my name is Alexis Duarmel. I'm a PhD student since September 2019, and I have been working 1 year as an embedded engineer in industry beforehand. So my subject is about self-reconfiguration of FPGA-based embedded systems. So for those of you who don't know what an FPGA is, FPGAs are field programmable gate arrays. So instead of executing compiled software bit streams, FPGAs use electronical circuits instead. In industry, you usually use big FPGAs matrices to execute complex designs. However, we are able to use smaller matrices instead with a technique called DPR, which stands for Dynamic Partial Reconfiguration. This technique allows systems to benefit from high performances in terms of fast computation. In my work, we focus on the management of those DPR-enabled matrices, which is challenge in itself because you don't execute compiled bitstream, but you make use of electronical circuits. So my topics are mappings and scheduling of task level of application management. More specifically, we try to manage a very high level of what we call a quality of delivery, which is a combination of quality of experience, which is what the user perceives when interacting with the system, and the quality of service, which is another metric used to represent how the system is able to perform the expected behavior. This is typically interesting because when you have an embedded system that is autonomous, it is driven by a software called mission management. Mission management is a meta application that sends application requests for the system to execute. Example, a drone that has different application through its runtime. For instance, a navigation phase, and then maybe a vision phase for trying to recognize some people at sea, for instance. So our work is about management of the systems, and we have designed a two-phase methodological pipeline. So the first step is design time, which allows us to make use of very complex algorithms to find near optimal mappings and scheduling to make use of at runtime. And the second step is, of course, runtime. So after having found some near optimal solutions, the runtime step is able to make use of those solutions, but it is not all, because you can encounter some unexpected situations. And in that case, you have to find other solutions, other mapping to execute the desired applications. And in that case, you have to find your own mappings and schedule, which is an NP-hard problem. So we have some hypotheses to reduce the complexity of those algorithms. I don't know how long do I have anymore?
Oh, you still have 2 more minutes.
Okay, fine. Thank you. Another challenge of this type of management is multiple application management. Because when you have 2 applications that are from 2 different nature, such as navigation for a drone and a vision application, you can't objectively compare the 2 applications. So we try to modelize the quality of experience from 2 different applications, 2 different nature, via a common metric called user preference, which allows us to objectively compare 2 applications. And when the user tries to reach what he thinks is the highest maximal quality of delivery, the system autonomously changes mappings and the schedule, so which tasks is being executed on which resource, to try to find the best way to execute the application. So we have what we call scenarios, which is what kind of execution mode for which application are we trying to execute. Execution mode, for instance, for video encoding application can be image resolution or frame rate. And of course, when we try to have multiple applications running on the system, you can try to dynamically change some parameters from an application to reduce the complexity of what you are trying to compute on the system. Okay? So at the final sentence to present my work, I'd say that what we are trying to achieve is hardware acceleration at a reduced cost, and by trying to achieve some real-time performance, as in a sense that we are trying to reach the execution time deadline, not to drop any service online. Thank you very much.
Thank you very much. Okay, so the next one is Abdelhamid. And also a warm welcome to you from the audience. Very good. And then we are eager to hear about your PhD.
Thanks for giving me this chance. Hello, everyone. I am Abdelhamid Gara. I am a fresh PhD student from the University of Burgundy, Lib Laboratory. I just started my PhD since this last November. Also, I hold an engineer and a master degree from the Higher School of Computer Science, Sidi Bel Abbas, Algeria. My topic is about self-management of security service in the Internet of Things. This subject is around 2 points. The first one, ensuring security services in the Internet of Things. The second one, try to adapt this solution with the autonomic computing in the IoT system. I asked some research question here about what are the main challenges investigated in both topics, IoT security and self-management of IoT security by researcher. What are the open issues in